So let's talk a little bit about solutions in conductivity. Conductivity simply means, does it conduct electricity? Well, if there's ions in solution, a solution will conduct electricity. Remember, an ion is a charged atom. Two types of ions exist. We have cations, which are positive, and we have anions, which are negative. The term for a solution that has cations and anions in it is an electrolyte. You've probably heard that term before in terms of sports drinks like Gatorade and Powerade. They are packed with the ions that we lose when we sweat, so you rehydrate a little bit quicker when you drink those sports drinks. A non-electrolyte is simply a solution that does not have ions in it. These are things like sugar water or alcohols or hydrocarbons. They are non-electrolytes. They do not have ions in solution. In the lab, how do we test for ions? Well, we test the conductivity. If a solution has ions in it, it will conduct electricity. We can test this two ways. We can do it with light bulbs, or in small group, you're going to do it with a very annoying beeper. So we're going to test the conductivity of a few samples and determine whether they are electrolytes or non-electrolytes. We're going to use this light bulb, and if a solution is an electrolyte, then it's going to be a very bright light. If it's a weak electrolyte, it's going to be a very dim light, and if it doesn't light up at all, it's a non-electrolyte. So let's start by testing distilled water. If you see very closely at the distilled water, you get the filament is barely glowing there. It's a very, very low light, which means distilled water, which is just pure water, is a very, very weak electrolyte. So what does that mean? That means there are some ions in solution, but mostly the water itself is just existing as molecules. It's just H2O. But H2O does break up into ions just a very little bit. It'll break up into H plus and OH minus ions. Those are the ions that are causing the conductivity. When it comes to the water itself, it's mostly molecules and only a few ions. That's why the light is very, very dim. So now let's test some tap water. You can see the tap water gives us a very low light. A little bit stronger electrolyte, but still not very strong. What we're getting here is a little bit of the dissociation of the water into H plus and OH minus. But the real reason why this light is a little bit brighter is because tap water comes from the groundwater or from another source where there's ions already in the water, like calcium and magnesium and nitrate. And then sometimes Omaha or other cities put other ions in the water, like fluoride. There's ions in tap water that make it conduct electricity a little bit better. That's why the light is a little bit brighter. So let's test vinegar next, and you can see we get a little bit brighter light still, a medium light, which means vinegar is a good electrolyte. When you look at the formula of vinegar, you see it's CH3COOH. Well, if we have a bright light, that means that substance breaks up into ions. So there's going to be a few molecules in solution, but we get mostly ions. We get H plus and acetate ions. So there are a few more ions than there are molecules, which is why the light is a little bit brighter. Next, let's test solid lead nitrate. So when we test it, we see we get no light. If we get no light, that means it is a non-electrolyte. Lead nitrate in solution, you will see, will conduct electricity, but in its solid form, there are no ions. If there aren't any ions, it's not going to conduct electricity. We need water to create those ions. So let's go ahead and test the solution of lead nitrate. You can see that the light is very bright. Lead nitrate is a strong electrolyte. That's because the solid lead nitrate breaks up into lead ions and nitrate ions, and there's lots of them. So there's a very high conductivity. Let's test ethyl alcohol. You can see we get no light. That means ethyl alcohol is a non-electrolyte, which means it does not break up into ions. It stays in its liquid form. There are no ions, just all molecules. Now sugar water, when we test that, you see we get a very, very low light. In fact, it looks a lot like the distilled water sample. Well, that's because the sugar is dissolved in distilled water. The distilled water is causing that filament to glow right now. The sugar is not responsible for that. Sugar is a non-electrolyte. You can dissolve sugar in water, but it does not break up into ions. It just dissolves in water. So when you take C12H22O11 solid, it just becomes C12H22O11 aqueous, dissolved in water. There are no ions in the solution. It is all molecules.